Assalamu alaikum. I'm Faridu Mormana and my ID is 20021. I will be starting my presentation for our microwave engineering course that was for 4741 and the presentation topic is rectangular waveguide. So let me share my screen. Okay, so I'll be starting my presentation. First, let's talk about what is actually a rectangular waveguide. A rectangular waveguide is a hollow metallic structure with a rectangular cross section that guides electromagnetic waves. And for this case, we have considered our rectangular waveguide is placed along XY plane and the wave is propagating in the Z direction. And it is mentioned here as well. So now let's talk about different kinds of wave was propagating in the rectangular waveguide. So for this case, we will consider two types of waves, that is TM and TE. So these are the two primary waves. So first let's talk about TM propagating along the rectangular waveguide. TMF is the transverse magnetic wave. And well, if a transverse magnetic wave is propagating in the rectangular waveguide, we consider that the magnetic field has no components in the direction of the propagation. And at first, we have mentioned that our direction of the propagation is on the z-axis, so that's why each z is considered as zero. So, and it can be a question that why hz is zero or why this magnetic field has no component along this direction, because our magnetic field is entirely transverse along that plane. And we can see here are the basic four field equations for this case as h z is zero. So we don't have this equation. There are main four equations ex, y, hx, and hy. So here can be different kinds of modes operating for this case. A rectangular wave actually supports different kinds of modes. Primarily for TM wave, there can be four types of modes that is mentioned here. So let's talk about the first one. Here I have mentioned that it is TM1. So first, it is considered the first propagating TM mode, and for this, it has the lowest cutoff frequency. And what is this cutoff frequency? Is we'll consider it later. Later. So now let's talk about the second type of mode, and it is considered the higher order mode, and it has higher cutoff frequency than the previous one. Let's talk about the third mode, that is considered as a crosswise field variation increase. In this case, the field variation increases, the crosswise field variation increases, and the nodes to be mentioned here, more electric field nodes in the y direction. And for now consider a generalized case, which can be the M and N, and for this case, M and N values is a general scheme. So you can see in this picture as well, for different types of frequency, we get different modes. At this point, now let's talk about the PE wave propagation. That means transverse electric wave propagation. When PE wave is propagated along the rectangular waveguide, we consider there is no electric field component along the wave of the propagation and the way of the propagation. For this case, EZ is zero. If we consider other hand, like our rectangular waveguide is placed in the XZ plane, then the wave is propagated in the y direction, and then EY component will be zero. For this case, EZ is zero. So there is main four field equations for our case, that is EX, EY, Hs, and Hy. These equations must be wrapped beforehand, and we get the value Hs, and from this basically we get this four equation and Ez is zero as I mentioned. And uh, there may be another question that why this component on the component along the wave of the propagation is we don't consider or is zero. And for this case as well, the electric field is entirely transverse and the wave is guided along the waveguide. That's why we consider the Ez value to be zero. So for the E wave as well, there can be different types of modes uh, according to the frequency component. So most can be T10, T01, T11. These are the names that was given as a convention. So these are the frequency equations, and a point to be noted, if you consider both the TE and CMO, both are propagating in the rectangular waveguide. The lowest order mode is here TE10. It is considered as the lowest order mode if both the TE and TF wave, TM are propagating along the waveguide. So this mode is considered as the dominant mode. And here is a point to be noted that a a phrase that is cut of frequency that is mentioned that will be considered later uh, have what is said if we just rewrite the sentence that is most commonly waveguide dimensions A and B that we have seen in our main picture here. A and B are most commonly waveguide dimensions A and B are chosen in such a way that cut of frequency allow only the E10 mode to exist in the waveguide. So here may be a question that what is cut of frequency? So we'll be discussing in a short. Okay. Now let's talk about what is cutoff frequency. The cutoff frequency is a crucial component in the website design. It is considered as the minimum frequency at which a particular mode, it can be TE or can be TM as well, can propagate inside a waveguide. So for the generalist case, this term or the cutoff frequency is a must to be considered because below this frequency, the wave actually does not propagate. Instead, it becomes an evanescent. That means if we consider a frequency below the cutoff frequency, that means the wave will not propagate along the rectangular waveguide. It will evanescent or it will decay exponentially. So here is the equation of the cutoff frequency for a general case for both TE and TM. So FCMM 1 by pi to 1 epsilon, and this is the term. And as I mentioned before, A and B was the width and height of the rectangular waveguide. In this picture, it has shown. Yeah. And M and N can be any value, but the value must be contained 0. And this value was mentioned in the here in the different modes of T wave. It can be both for the case of TEM wave and TE wave. So M and N, this value is considered in any um, generalized case in kinds of mode for this case. And let's talk about now the dominant mode that we were mentioning before. Here, T10, and you can say that M and N value. M value in this case is 1 and N value is 0. And if we put these two values, we will get this sort of frequency. So, here. And T10, it is considered the lowest cut frequency. Here, it was mentioned that most commonly waveguide dimensions can be architected in such a way that cutoff frequency allow only T10 mode to exist in the waveguide. So here, the T10, we got the equation of the T10 from this cutoff frequency equation. Okay, these were the basic phenomena that we need to consider for designing or using a rectangular waveguide. That it can be of uh, different ways can be propagated, TGN and TM mode, field equations, different kinds of modes. It can be different kinds of modes. And while designing, we need to consider that the cutoff frequency. It is one of the most crucial points that needs to be noted. So now let's talk about why we use this rectangular waveguide. It can be have it can have different applications. We can use it in multiple microwave transmission for the case of satellite and radar antennas, high power RF systems, as well as designing any sort of filter or coupler device. So let's talk about few criteria or few applications and how it is. So let's talk about uh, application sector, that is the radar system. Rectangular waveguides are most commonly used in the transmit and to receive high frequency signals in the radar system. So it's a very crucial component in that application area. So in the communication sector, obviously, this waveguide is of great use. They are very essential for the point-to-point communication system. Uh, uh, so that major character that needs to be considered. So as there is also mentioned that it's also used in an antenna fit system. So waveguides serves an effective transmission lines between transmitter and receiver. So the major application area of this uh, are rectangular waveguides in different communication radar system and antenna fit system. Also, it is also used in filter and coupler design. For it has some basic uh, advantages over any other waveguides. So here I have discussed different aspects, different sectors of rectangular waveguide. So with this, I'm stopping my presentation. Thank you very much for watching. So I'm stopping my screen here.